Hi rates, welcome to this video on creating a table of values and determining if a point lies on a line. So there's two separate things there. Firstly, can you create a table of values from a rule? And the second thing is, can you determine if a point lies on a line? I didn't say this in the Cartesian plane review lesson, but I should have said it. You obviously notice there's 4 different sections to our Cartesian plane. These have special names. This is called quadrant 1, and then this is quadrant 2, quadrant 3, and quadrant 4. If you remember, the top right one is 1, and it goes around anti-clockwise from that. That's kind of how I remember it. But that's the naming convention we have for each quadrant. We'll start off by talking about a table of values from how to create a table of values from a rule, because that's sort of where we left off last video. And perhaps we'll ask you something like this. Create a table of values for the following rule and plot it in Desmos. I'll come to Desmos in a second, but firstly we're going to concentrate on moving this. So this is a rule. When we call it a rule, sometimes it's the same thing as an equation. It tells you the relationship between the two variables. There's an x and a y, and they are connected by this rule. So to find the y coordinate, it equals 2 times the x coordinate plus 4. I'm always going to start with 0. So let's say the x coordinate is 0, or 1, or 2, or 3, or 4, or -1 and -2. I typically find it's easier to do the x coordinate first. Just pick some random values. And then you're going to start substituting in your x coordinate into your equation. So I'll show you what I mean by that. If x equals 0, my equation is this. If x is 0, then I'm saying I'm going to substitute that to be a 0. I'm saying 2 times 0 plus 4. So I know my y value will be 2 times 0, which is 0, plus 4 is 4. So if x is 0, I know my y value is 4. This process is called substitution. We did that in our last unit of work on linear equations. But it starts to tell you a story and shows you the pattern of how the x and the y variables are connected. Let me do x equals 1. So if x equals 1, then, well, y is 2x plus 4. That's a 4, not a very good 4. I'm saying y equals 2 times 1 because I'm swapping the x for a 1 because I'm saying x is 1. 2 times 1 is 1 plus 4 is 6. So when x is 1, y is 6. So I'm beginning to plot my points here and seeing what my table looks like, and you'll eventually see a pattern. If x equals 2, then y equals 2 times 2 plus 4. 2 times 2 is 4 plus 4 is 8. After 3 points, you can kind of see the pattern, 4, 6, 8. I could start substituting in the 3 and the 4, but I know that it's going to be 10, it's going to be 12, this one will be 2, and this one will be 0. A really easy way to check is just, I'm not too sure if this one's right. I'm just going to say if x is equal to -2, and I'll substitute it in just as a check. So y equals 2 times -2 plus 4. 2 times -2 is -4, plus 4 equals 0, which is what I got. So I've created a table of values from a rule. This is a really useful skill because you can now translate these points, because each one of these is coordinates, remember, and plot it in Desmos. So when you do your work this week, there is a link to a site called Desmos Graphing Calculator. It's just desmos.com/calculator. I put instructions in there, but what you do is you press this add item and you can add in the table, which is exactly the same as our table, except theirs goes vertically. So my x values were -2, -1, 0. So you notice that my table is going vertically here, but in where I was working before, it's going horizontally. It doesn't make any difference. And I can start putting in my points. So when x was -2, y was 0, and it went up by 2's, didn't it? And as I'm putting in my points, you'll notice that over here, points are being plotted onto, there it is. onto my Cartesian plane. So Desmos is just a virtual Cartesian plane. You can zoom in and out. It is really obvious when you plot these on a Cartesian plane, and the reason why using a Cartesian plane is so powerful is, say for instance I had a 7 here, you can just visually see straight away that point is not right. So I can change it back. And when we're talking about linear graphs, because this topic is called linear graphs, I also should have said this at the start. When we talk about linear graphs, the word linear means straight line. Well, it means a line. So everything we're doing here with a linear graph, if you graph it and it's not a straight line, you know instantly you've made a bit of a mistake. We're talking about straight lines. Everything's a straight line. So our points are in a straight line. So that is the process. This is our first success criteria of creating a table of values from a rule. I have my rule, y equals 2x plus 4. That connects the variables x and y together. It tells me what y equals for each value of x. And also it tells me what y could equal for each value of x. That's what I just said. I substituted in different x values into my rule to find out what the corresponding y values was. And that was this process of substitution. I then created my table of values, and my table of values is just 1, 2, 3, 4, 5, 6. It's 7 different coordinates, which, I mean, you can do this by hand, but Desmos is quite a powerful tool to use. And we put in a table and we plotted our points and we saw it was a beautiful straight line. So that's the first part of this online lesson. The second part is perhaps we want to know, do the points 2, 1 and 4, 2 lie on the line y equals x take 1. So this is the rule that connects together x coordinates and y coordinates. So this is an x and this is a y. And it basically is saying, do these points abide by this rule? For instance, if I have my linear graph, if I have my Cartesian plane over here, and here's my line, I just made it up. I have 2 points. One of them is this point and one of them is that point. You can see one of them lies on the line. In other words, it's following the rule, or this one here isn't following the rule. And there's 2 ways to figure this out. The first way is using algebra. The second way of figuring it out is by very quickly, you can plot these points and you can put this line into Desmos. I'll show you that way first because why not? So if I put in my line, I can't remember what it was now, y equals x take 1, there's my line. I can also put in the point, I can't remember what point it was, 2, 1. And I can see that point does lie on the line. And I can also see if I put in my other point, 4, 2, I think that was the other point. Yep. That one doesn't lie on the line. So graphically, I can see that the 2, 1 does lie on the line and the 4, 2 doesn't. So before I even start my algebra, I know that one does and this one doesn't. But let's try to figure it out with algebra as well. What you do is you substitute in these 2 points into this equation. So my equation is y equals x plus 1, minus 1, excuse me. I'm going to substitute in the x for the x and the y for the y. In other words, the y is 1, the x is 2. So if this point lies in the line, then this will be true. 1 equals 2 minus 1. Well, that is true. So therefore, we know it lies on the line. And I'll just say lies on the line. Lies on the line. With the other example, 4, 2, I'm going to substitute in my 2 points. So the x is, in this case, 4. My y is 2. 2 equals 4 minus 1. Well, 4 minus 1 is 3. So that's not true because it doesn't work. So therefore, we can say 4, 2 doesn't lie on the line. This process is really great. This is just another example of where you can use substitution. Sometimes it's good to do it algebraically. It's also very powerful to come back and check if you graph it. You can see exactly where a point is, if it's on the line or not. So that's actually our second success criteria in this short lesson. the very last thing I want to show you, and I'm not going to talk about this too much because this makes up a large part of your work this week, is this concept that the general equation of a straight line is y equals mx plus c. So y equals mx plus c, you're going to hear that a lot in the future, but this is what we call the general equation of a straight line. This week's work will require you to find out what the m is and what the c is and how that changes a straight line on the Cartesian plane. So far in this, we talked about here y equals 2x plus 4. And the one above here, it was y equals x take 1. So you can see that these two equations are in what we call the general form. Because in the first case, the m is 2. In the second case, the m is 1. Remember, there is a 1 there, we just don't write it. And then the c in the first case is a 4, and in the second case is -1. So throughout the week, as you're doing your work, you're going to encounter this, and you're going to be trying to figure out what the m does to the line and what the c does to the line. That brings us to the end of this lesson. I hope you found it useful and you now know how to create a table of values from a rule, and you can determine if a point lies on a line.